So we've learned something about the number of moles of each different substance, but how does that pertain to a balanced chemical reaction? Balanced chemical reactions tell me that 4 sodium moles react with 1 oxygen mole to give me 2 moles of sodium oxide. And then they start asking me questions. So now let's watch what happens here. What is the number of moles of oxygen needed to react completely with 4,6 grams of sodium? So what I'm going to do is underneath sodium, I'm going to write 4,6 grams. The minute I've got a mass, I'm going to also quickly determine its molar mass, and it's 23. And the other information that I'm being asked for is the number of moles of oxygen. So I'm first going to work out the number of moles of sodium because I've got enough information about that, and that is mass over molar mass, which is going to be 4,6 divided by 23. And I land up with 0,2 moles. Now I look at a mole ratio between sodium and oxygen, and I say that sodium is to oxygen as, O2, as 4 is to 1. Where did I get that? 4 from there and 1 invisibly from there. But I don't have 4, I've got 0,2 moles of sodium. What did I do to 4 in order to make it 1? I divided it by 4. So I'm going to now take that 0.2 and also divide it by 4, and I get 0,05 moles of oxygen, and that is what I require to react with that given mass of sodium. What is the mass of sodium oxide that is going to form when 4,8 grams of oxygen reacts completely with sodium? So I'm just going to rule a bit of a line over here, down there, and we're going to work underneath a sort of balanced equation. So this time I'm going to say that I'm asked the question, what mass of sodium oxide will I get or forms when a mass of 4,8 grams of oxygen reacts? The minute I'm dealing in masses, I work out the molar mass, and oxygen is 32. I now go number of moles is equal to mass over molar mass, which is equal to 4,8 divided by 32. And I land up with 0,15 moles. Then I need to look at mole ratio. The relationship is between oxygen and sodium oxide. And I have got 1 mole of oxygen is to 2 moles of sodium oxide, so 0,15 moles, 15 moles. What I do to the number 1 to make it the number 2, I doubled it, and I get 0,3 moles of sodium oxide. I take that 0,3 up here, number of moles, 0,3. And I say I would now like to know what is the mass that I have. First I need to know what is the molar mass of sodium oxide, and it is going to be 23 times 2 because of sodium, plus 16 because of the oxygen, and I get to 62. Then I go mass is equal to number of moles times molar mass, 0,3 multiplied by 62, and I land up with 18,6 grams. It's the same routine every single time. The last one that's given over here is what is the volume of oxygen measured at STP, which must react completely to form 6,2 grams of sodium oxide. So let's take that all up. In fact, we can maybe just clean that away. There we go. Yeah, that'll work. And now I'm going to say question mark. What volume of oxygen? The minute I'm working with volumes at STP, I look at molar volume being 22,4 decimeters cubed per mole. Anyway, don't worry about the unit right there. 22,4 is all right. And I'm going to say I'm looking for 6,2. I've got a mass of 6,2 grams of sodium oxide. The molar mass of sodium oxide, we just worked that out a minute ago, and it was, I think, 62 if I'm not mistaken. And therefore, I can work out the number of moles. Number of moles is mass over molar mass, 6,2 divided by 62, which is equal to 0,1. What am I relating to one another in this question? I'm relating oxygen and sodium oxide. So what is the relationship between sodium oxide and oxygen? There's an invisible 1 over there, is to 2. But I don't have 2, I have 0,1 moles of sodium oxide. What did I do to the number 2 to make it the number 1? I divided by 2, so I do exactly the same thing, and I get 0,05 moles of oxygen. I take that 0,05 up to the top, number of moles 0,05, and I say volume is equal to number of moles times molar volume, 0,05 multiplied by 22,4. And I land up with an answer, I'm going to just put it in a different color, of 1,12 decimeters cubed. So that's stoichiometry. It's really just about how do we relate our calculations on molar gas volumes, masses, and we can also have number of particles and number of moles, all when relating to a balanced chemical equation. Let's try another example. So we've got some nitrogen and it reacts with oxygen as indicated by that equation. Determine first the number of moles of oxygen that combine with 0,5 moles of nitrogen. So I'm going to say I've got 0,5 moles of nitrogen. I don't have to calculate anything. I just need to quickly literally go into a mole ratio between the nitrogen and the oxygen. So nitrogen relates to oxygen as invisible 1 relates to 2. And I have been told that I have got 0,5 moles of nitrogen. And therefore, what did I do to the number 1 to make it the number 2? I doubled it. So I've got 1 mole of oxygen. Next question, what is the number of moles of nitrogen dioxide which form when 5 moles of nitrogen react completely with oxygen? Again, easy. I've been given the moles already. And I'm only looking for number of moles, so I don't have to look at masses and volumes or anything like that. I'm simply going to say, what is the relationship between nitrogen dioxide and nitrogen? And I have got an invisible 1 and a 2. So it's 1 is to 2. They tell me that I have got 5 moles of nitrogen. What did I do to the number 1 to make it the number 2? I doubled it. So I double this and I get 10 moles. And the answer is 10 moles of nitrogen dioxide. Next question, what is the mass of nitrogen dioxide? So I'm just going to come underneath this equation and I'm looking for mass of nitrogen dioxide, which forms when 21 grams of nitrogen. The minute I've got a mass, I look for the molar mass, so that was mass. Molar mass is going to be nitrogen, which is 14 plus 14, and that's 28. Number of moles, mass over molar mass, is equal to 21 divided by 28, and that gives me 0,75 moles. I now need to establish a mole ratio between nitrogen and nitrogen dioxide. So I'm going to say, let's just move this up a little bit. Nitrogen was to nitrogen dioxide as 1 was to 2, and that came from the balanced equation, but I haven't got 1 mole of nitrogen. I've got 0,75 moles of nitrogen, which means I need to double that, and it's 1,5 moles of nitrogen dioxide. I can take that up now to the top, and the question was, what is the mass of nitrogen dioxide that forms? So I need to work out molar mass of nitrogen dioxide. It's going to be 14 plus 16 plus 16, so I think it comes out to be 46. And I land up with mass is equal to number of moles times molar mass, which is 1,5 multiplied by 46, and that turns out to be 69 grams. Then on to the next one, we have got what is the volume occupied by that same mass of nitrogen dioxide at STP. So I know that mass is 1,5 moles. So I'm going to say that simply volume is number of moles times molar volume, which is 1,5 multiplied by 22,4, and I land up with 33,6 decimeters cubed.